I started kind of thinking about this starting this year about this talk, or generally like we want to talk about this more because it's criminal not to talk about like a code base that has been up for so long and it's still like in production, and there's a lot of learnings that we can share with the community, and like uh, mostly there are pitfalls or things that we did wrong that everyone should avoid. This is part one because I don't know how many parts there will be. At the end, I'll also list down the topics that I did not cover so far. A bit about me. I like to call myself machine whisperer because that sounds cooler than just saying I'm a software engineer to general audience. I do make films whenever I can over the weekends. Uh, I use Emacs for some of my filmmaking things, but that's another topic for another day. Yeah, I use Clojure and Emacs at work. I mostly work with databases and distributed systems at Helpshift. Helpshift is a mobile support SaaS. Uh, these are some of our scale numbers, and these are mostly from the um, repo that we are going to talk about, the monolith. So it does scale. So there is one usual discussion around if monoliths can scale and if they can stand the test of like different scale levels. So definitely that is something that we have been able to do, but there are more challenges, and we'll come to that. Goals of this talk are like explore like patterns that emerge in a Clojure repository over time, and there are like some patterns that need solutions, and what has worked for us, I'll just discuss that also. There are some pitfalls that you should definitely avoid, especially like your code base gets bigger, but that code base is one part of it. We'll come to contributors also, and like how contributors also matter, and like uh, what what are those numbers. uh, we will definitely not talk about microservices approach, not because it's a particularly bad approach, just because it's like a documented thing. uh, there is enough literature around it that kind of talks about how can you move from a monolith application to a microservice application. Of course, there is even more literature about what are the downsides of microservices. I think that is language agnostic. Most of the knowledge can be applied to even Clojure, even if the literature is for some other language. Same with like event driven approach, like generate events and like that sort of stuff. We have done this quite a lot, but we won't be talking about it because it kind of goes into the realm of software system design and architecture and that sort of stuff. And I want to focus this talk more on the language, specifically on like what things break down when we use Clojure for a monolith. So before starting, like we'll just like kind of define what a monolith is, and I want like you guys to also contribute here, saying like what you think monolith is. I think this is the definition I found the most apt, which is like software system that is composed of single large tightly coupled code base that kind of defines our internal repo. But I would like if there are other definitions or anything that you would like to add to definition of monolith when you think about it.
I think for me, it's also the runtime, um, which is singular for the entire application. So if you have 100 modules, they're all operating from within the single runtime.
Got it. Got it. So like a single service that does everything.
Yeah.
Okay. So like we call our repo Moby. These are like some of the numbers just to show you scale of things. Like 500,000 lines of code that we have written over the course of almost over a decade. Half of it, well, not half of it, but good part of it are tests. These are the number of contributors over the last 10 years. That's like a crazy number. Even I was like double checking that number. This is slightly on the higher side because The command that I ran even considers like people who have contributed to just one single Clojure file, but I think a realistic number is close to 140, 130 Clojure contributors. Uh, there are like around 21 services in this monolith. So I think that kind of breaks the definition that we just discussed, that okay, it's just one service. We host more than one service, but it's a single jar and it's a single repository that hosts all of these services. uh, these are the this is like year over year what we saw in number of contributors. The first year of this repository was in 2012. It was somewhere around like 17 people that were contributing to this, and now like it's close to 70. That's a lot of people contributing to one repository, and there are problems there also. But let's see what this repository does. Like, please feel free to interject if you have any questions about these two slides. So we'll just like do an overview of like what this repo does. This is like a very simplistic view of what it does. But you have entry points, right? You have bunch of HTTP services and also some Kafka consumers or some jobs from where something is triggered, either a HTTP request or a event is consumed or a job is triggered. And then you have a second layer, which is like you're kind of processing the input, you're sanitizing it, you're getting into a structure that you want. And then you have core business logic. This is basically the meat of the product where everything happens. This kinds of encap all the rules, all the constraints that the business wants. Of course, there are like utilities and libraries that it depends on. And then you also have side effects, like you want to store this to a database, you want to send it to a event stream for analytics, you want to send out emails, that sort of stuff. Like the core business logic kind of triggers that. So like this is very important to understand like what all problems we face. But first problem that I would like to call it as a data mudball. Has anyone heard of this term? This term is, I believe, is not that famous, but just curious if anyone has heard of this.
Heard of what, Kapil? I can't see your share. Could you tell me the name?
It's the pattern, it's called data mudball.
Okay, no.
Okay. Of course, like with monoliths, like there's a lot of code, so making any changes is slow development for two reasons. One is like your tests are slow, which in turns makes your releases slow, but that's not the only reason. But now you have 21 different services that you have to release to. That becomes a problem in itself also, because like you have made a change to only one place. But first, let's look at data modball. What is this whole thing about? Even before that, let's look at like how do you get any side effects done in a Clojure program. So you have like, this is a completely fictional example, but you get the point, where what you're doing is I'm saying I want to add a fav, like I want to like a song, like this is kind of like a Spotify app. I give it a user ID and a song ID, and I want to associate the like to that song for this user. I'm doing a bunch of side effects here. Every function that is ending with a bang is a side effect, and it's like you kind of have to like order it because that's how you want it. You first want to store it in MongoDB, then you have to kind of update your search engine, and then you have to generate a few events, and you have to generate a few push notifications. Let's look at these two. One is called update the user in MongoDB, and the other is update it in Elasticsearch. Another way of saying this is, here we are using a let binding, and I want you to pay attention to Mongo result, which is being passed to Elasticsearch result, because it's like you want to take the result of that operation and then kind of store that into Elasticsearch, because you want both of them to be consistent. Of course, there are other ways to do this, but this is like the most straightforward way that you can think of when you're writing an app. Uh, if you want to kind of write it in a different way, you can say that, okay, I'll pass a hash map to this and first do update in Mongo and then update in ES. Because we are using comp, the order is reverse, but it's not so readable, and you can make mistakes. So we use this nice uh, function called thrush. It was written by Fogus. This is still used in Helpshift till date. Uh, so all it does, it's like you start with a value, and each function is changing that value and passing it to the next function. Okay. Uh, so thrush is like I start with the empty map, then update user in Mongo is like taking that empty map, doing its side effects, and returning a new map that is used in update user in ES, and so on and so forth. But you have to kind of change this update user in Mongo now because it is a singularity function. So this becomes something like this, like you have just one hash map, and then you are associating a new result with the same hash map. And this is like a general pattern that we started doing. Uh, and this becomes something like this because not only you are doing updating, but you are sending events and so on and so forth. uh, this is kind of very close to what we have in production. Also, we have a thrush with starting values, and we have a bunch of side effects. Now this is where the problem of Mudball starts coming in, because every function is going to accept the hash map before that and then add some output which is associated with the hash map, because you want to retain the values from previous function. It will for the first line it will look something like this, then the next function it will look something like this because Mongo result has been associated with that result, ES result, and so on and so forth. And this is by the end of it, it will look something like this. Uh, this looks something like this for us in production, and you have your mud ball. Uh, this I don't think is a problem just with the monolith. Even if it's like a microservice with the complex enough business logic, you can end up with something like this if you have a lot of side effects or a lot of things that you're kind of composing together. So, did everyone understand the problem so far? Like uh, where we ended up on?
Yeah.
Okay. So there are two solutions that we found around this. One is pneumatic plumbing, and other is something that we. Uh, this is a heavily inspired solution from plumbing, but the uh, syntax is slightly different. But the both ideas are similar. I'll just show you in this uh, example. What it is a custom thrush, but thing to notice here is along with the function, you are passing a key also. And the whole idea about this is that you are namespacing your output of each function, so they don't pollute the complete hash map. They can only change something against the ID that you associate with. This is something that we are still trying, but the problem that we showed with Mudball still exists. Another problem with Mudball is that in this whole thrush, a function can overwrite output of a different function. For example, Mongo result can be overwritten by a function downstream, like function later than update Mongo, and just overwrite it, and we won't even know it. And it's very hard to debug also. So these are the two solutions that we thought of. Uh, on top of it, Thrush itself is not really good at error handling, or if you think about it, it's just like a linear thing. But a lot of times, your execution is kind of like DAG, which is highlighted in plumbing also, where you can say that I want fetch song to be done, and then update user in Mongo and update user in ES can happen in parallel. Then wait for both of them to complete, and then you can then run send user event to Kafka and send like push notification in parallel. So that is kind of like a DAG which you can construct, and you can have different executors to execute it. Meaning, like, you can just say, I really don't care about if there are parallel edges in this DAG, but execute them serially. Or I want you to use this thread pool to kind of uh, parallelize or attempt parallelizing these parallel branches. So this is about data Mudball. The second problem is slow test build and releases. At one point, we had test builds that were taking around 3 hours, after which time our build system used to time out because that was like the maximum time it was configured to wait for. And this led to like a lot of slow development times. Biggest problem here is that if you change something in your business logic, right, you don't know what tests to run. So you what you end up with is running all the quarter million worth of test lines every time, which is not very optimal. So what we realized was we can create tooling around it, which is like a common pattern for big code bases where you can like just create a dependency graph of your changes and then do the same thing for your tests and figure out, okay, this is the only thing that has changed. um, so we construct a DAG and figure out, okay, what are all the namespace that changes. So here the tool can say, okay, the core business logic has changed, but only this service is impacted. Now you get two benefits for this. One is that you don't have to run tests for HTTP service 1 and HTTP service 2. You can just run tests for Kafka consumer. Other thing is you definitely know which service that you want to deploy to, because this change only concerns this particular service. Um, there are two tools that we came up with for this. One is line test diff. This is mostly focused on figuring out which tests to run. This is not very specific to what we have done in Moby, but you can apply it to any Clojure code base. As long as it's using Clojure tests, it will work. Other thing is written by Vedang, another Helpshift Clojure and Emacs person. He when he was with Helpshift, he created BB scripts, which lets you figure out which AOTs have been impacted, and then you, basically these are the entry points that matter, and then you can just say, okay, these are the services that you want to deploy to. So this comes to like uh, the end of two parts that I wanted to cover in this multi-part series. There were a few questions that came up when I asked on Twitter, on Slack, about like this talk, what you want to know. One question was about, is there any particular Clojure technology that can benefit, uh, can get the same benefits if microservices monolith? There is no particular Clojure technology, but we have been working on a way to create modules. These are like something similar to Java modules, where you can declare different code areas as different modules, and then you can declare dependencies. What this does is figuring out these changes, meaning like if the core business logic has changed, what all has changed, is more explicit than just relying on these tools. So that's one thing that we are trying out internally. It's not fully baked, so we are not sure of sharing it externally yet. Apart from that, we have had success in like cutting out a microservice out of the monolith. We cut out one product area from the monolith, and just it's its own thing now. What we realized was that we can get benefits of just the line test diff method or creating the DAG. And the downsides of microservices were more for us. And it's always contextual because for a big org of like 1,000 people, I think microservices is a better answer because now you can structure your teams uh, a specific way. But you also have an overhead of microservices where how do you do local setup with a lot of microservices? How do you do better debugging, because now you have not just one problem, but you have five problems because you have five different microservices that you have to debug. So I think that's something that we did not want to take on as a startup, but that's something that we are slowly considering and cutting out things. Again, creating a microservice is a non-reversible decision. It's like choosing your shard key in a database. you have to give it a lot of thought before you can figure out, okay, this is what the microservice looks like. The first step to that is what we are considering as the module. So if we can figure out a module inside the monolith and make it really make the boundaries really nicely cut out, then we can say this is a good candidate to create a microservice of. I think there were few more questions on a Twitter thread. One of it was, how do you make sure the consistency and quality of the code? I think there are a few tools that help, linting tools, but definitely there are few guidelines that help more. One thing that has worked marvelously for us is we stay away from macros as much as we can. We always ask this question that, can this macro be a function, and choose to write the function first, and if required write the macro. Usually we end up writing macro only for the syntactic sugar, and there is no added benefit, because like macros are hard to maintain, debug. uh, any challenges in understanding the internal workings of the app for being a monolith? Yes, this is a challenge for onboarding folks, and this is something that we still struggle today. I think documentation solves it to a certain extent, but it still is a confusing part for especially new engineers, because there are a lot of barriers that they have to cross. First is understanding Clojure itself, and then understanding a very complex code base. Uh, Third question I can answer with this is that every team owns the service and not the core business logic, and there's a separate team that owns the core business logic. This way, and since it's like a more mature product we developed over years, core business logic does change, but then it changes for a specific team. We never had an instant. We have less instances of two teams working on the same core business logic a lot. What we have seen is usually we end up changing the glue code or the integration of the HTTP service with some client more often than not. Um, yeah, this is something that I've been still working on, and it's not fully baked for the talk. One thing that I talked about it previously was modular monolith, creating modules so that you have some structure. They are like Lego blocks in your monolith, and you can like kind of swap out or figure out dependencies. Uh, there is a lot of learnings when we carved out a single microservice out of this monolith. Another very interesting topic for us is contracts that we use for services. There have been different approaches for this, so that's really important. Choice of database also, I think this is my thesis. I am not completely sure, but it does impact the kind of complexity you bring in your code base if you are not very careful about this. Uh, Topic close to my heart: concurrency, thread pools. There were few gotchas here when we were building things, not necessarily related to monolith, but if your code base is complex, these are the things that you have to worry about. And last but not the least, static typing is something that a lot of people have asked, but what I've realized is I don't know enough about static typing to compare the two. So first I'll have to kind of understand it myself, and then um, work my way and kind of compare it. I think this is something that is a very debated topic itself, and that's what I realized, that there's no one person who can compare it without a bias or fairly, because even if I start doing something in static typing, there's a history of such a long time for dynamic typing in this code base. It's again becomes a biased comparison. Okay, with that, uh, thank you for joining in. These You can follow us on Helpshift Engineering. We try to post blog posts not just about Clojure, but all the engineering things at Helpshift, including amazing SDK development that we do. There's a lot of challenges that we solve. Tanuj can add there. And I'll pause for questions now and stop my sharing also.